Okay, so uh, hi everybody, my name's Andy Turner. I work for EPCC at the University of Edinburgh. Hopefully you can all hear me. And I just wanted to welcome you along to this course on reproducible computational environments using containers, which is going to introduce both Docker and Singularity. I have a few people along helping me. I'm my co-instructor, who is Jeremy Cohen, who is from Imperial College. Jeremy's going to lead the teaching the Singularity stuff tomorrow, and I'm going to lead today on the Docker part of the course. We also have a few helpers along with us today to help you if you get stuck or you have any questions. And Adrian, Holly, Stefano, and Will. So thank you to all of them for putting their time aside to come and help us out today. If you get stuck, please do either put your hand up or ask a question in the chat, or even just shout out. If we can solve the problem quickly, we'll just do it in the session. But if you need a bit more in-depth help, they'll be able to take you off into a breakout room to help you individually with more detailed questions and things like that, and then you can come back into the main room afterwards. So we've got today on Docker, and we'll work through the material. Now this course originally wasn't a carpentries course at all. Now it's in the carpentries incubator, which means that it's being worked on and developed as for a potential future carpentries course. But we do teach it in the sort of carpentry style. So what that means is that we'll work through the material. There's not slides and practical exercises maybe you've seen in other courses. We'll work through the material together, and I'll do things on my screen and then ask you to have a go, and we'll check that everybody's keeping up and understanding and gets a chance to ask questions as we go along. Now I'm going to share my screen so you can see what's going on and just check that that's working first of all. So let me do that. So this is the course website. Of course, I will occasionally make a mistake and try to scroll on the display of the screen itself, which means I think I'm scrolling, but I'm not. I'll try and catch myself doing that. It's always a mistake with me. And I also have a terminal window, and I'll make that a bit bigger as well so that people can see the font there. So you can see what I'm typing and what I'm up to as we go through the work together. Fine. So the first thing I wanted to go through, unless anybody has any questions right now, is just a little bit about the general information or about the setup for the course. Sorry. So there's two things we've got this course website, and I will also paste, which you can get to from the ARCHER2 website where you registered for the course, but I'll also paste in the chat the link here. Oops, if I can actually manage to work my keyboard, the direct link to the website here, and that contains all the material and all the information for the course. The key things before we start is this collaborative document, which is called an Etherpad, and again I'll paste the link directly in the chat in case you wanted to click on it from there, but you can always get to it from the website as well. And I've got it open in a tab in my browser here. Let me make that, oops, sorry. I have clicked something I didn't mean to click. So let me make that a bit bigger again. So I'm going to start with section 1. You can either follow along on my screen. If you've got it open on your own computer as well, that's fine too. You can follow along there. So the first section is a bit of an introduction to containers and the theory behind them. So in this section, there's not a huge amount of practical work, or at least practical stuff we're going to do, but we're going to talk a bit about the concept of containers and just try to set the context as to what they are and why they exist. Okay, so what we're trying to do with this first session is look at what containers are and why they may be useful to people people working particularly in academic research, which is where this course is available. And address like why software depending on software leads to this configure management problem, and identify the problems that they can propose research and give some examples of how containers could solve configuration problems. So certainly in this lesson, containers are one disclaimer is that we're already doing a very short introduction to the technical background here. So most of the time you'll be using Docker commands, and it's very practical. It all should just work. But there is a lot of technical stuff underpinning that where we just don't cover in this course. So we give a broad or a high-level overview of what containers are and how they're useful. But we don't delve too much into the technical details. We're more interested in having at least some concept of what containers are, and then how you can usefully use them in your research or in your work. This may be a stepping off point for if you want to learn more about the technical details on courses or by reading the documentation. That's fine. And of course, if you have particular questions, we're happy to try and answer them. I may say, oh, well, that's too technical for now. We'll need to take a back seat and we'll answer it at the end of the session if there's time or something like that. But we will do our best to answer your questions as we go along. So the first thing I want people to do is actually an exercise. So I've talked for a little while now, so there's a chance here. So I want you to think about the challenges you may have experienced in using scientific software or software in general for your research. What are the what are the problems you've come across in any setting, be it on a remote system, HPC system, if you use one of them, be it on your laptop or workstation. Can you have a think about them? And I would like you to add some ideas, maybe an idea or an issue that you've come across to the Etherpad. So let me write it in, let me create a section for this. So exercise 1. So you could add your own, please take a few minutes. We'll take a few minutes. You can add issues there, things that you've come across. If you see an issue that somebody else has added that you think is an important one or something that you've experienced as well, then you can add a +1 to it or a +2 if there's already +1 or something like that. So please just take a moment to do that. We're at 10:15 now, so I'll give you 5 minutes for that until 10:20 for you to have a think about it and add something useful. Helpers and instructors, please feel free to add things as well, of course. Okay, so we've got quite a few responses there. People could, I mean, if you're still adding things, keep adding things because I'm going to talk anyway for a moment. I think what you can see here is a lot of the common issues people see with software. Things like transferability of environments and problems with versions. You've done something, you want to share it with somebody else, or even you want to come back to it yourself, say a year in the future, and do the same thing you did again, and suddenly it doesn't work in the same way, and you spend a long time trying to pick that apart. The prerequisites haven't been published or poorly understood, so it's very difficult to get into a state where you can actually reproduce the work, either again yourself or that somebody else has done. Dependency hell is a common term. I'm trying to install a set of stuff, and the conflicting dependencies mean that it's really, really hard, and you just feel like you're going around in circles. Outdated versions which don't work anymore, particularly with HPC. Things like the backend nodes aren't on the internet, so you can't easily pull data or software requirements or things like that. Poor documentation. It's difficult when you get access to a new machine or the cloud. You've tested something on your laptop and it seems really nice, and you want to really scale it out, so you've got access to a remote system of some sort, be it cloud, be it HPC, be it whatever, and then suddenly you have to revisit the whole installation and the whole workflow to make it work. Problems of installing software as well. Just the installation process is difficult, cumbersome, requires privileges that you don't have, and things like that. These are really all very common issues with software. So you can see here a lot of your things you came up with just match on to the sorts of examples that are in the course. And I think the only one or one of the ones that didn't come up is this last one. Is you've written a package for other people to use, but you get lots of people saying they can't install it and can't make it work, and suddenly you feel like you didn't sign up for this level of support for the things. And as And the key, the source of the root cause of all this is this dependency. How is this fact that there's a dependency of software between different bits of software, and if you only have one actual computer to install on things on, you can't, managing that dependency becomes very problematic, because different projects you're working on or different things you're doing may have conflicting dependencies. So you don't have the flexibility required. You can't buy a computer for every single project installer. And I mean, there's a sort of exercise here. I'm just going to skip it, but as you can imagine that this, particularly when we're doing science or research of any sort, actually, not just scientific research. I mean, research in arts or in humanities and other fields. This really has a concrete impact both on the quality of work that people are able to do, because they spend lots of time dealing with software installations rather than actually doing their research. Also in the quality of how we can share and collaborate around our research, and how we can actually reproduce the results we've got, even if, as I've said, that doesn't necessarily you reproducing somebody else's results or somebody else reproducing your results. It's you reproducing your own results when you come back and somebody has a question on it a year later, after you've forgotten a bit about what happened, and maybe your underlying operating system install has changed on the computer you did the work on, and things are very, very different. One of the reasons that containers have arisen, or one of the key use cases that containers have arisen, is to try and address these software dependency challenges. And fundamentally, I think, I mean, at least in my head, I mean, this isn't I guess the sort of technically correct way to think of things, but it's essentially having like lots of little separate computers that you can install and keep isolated for that bit of work, and that you can keep in a format that you could reuse, or you have some sort of record of how the software issues you use for that were resolved, or what the versions were. You have an artifact that can be kept that's not just the writing notebook, which might have missed out steps. It's an artifact that could be reused by the computer to regenerate that computer or that software environment we're using. So a container, in my head anyway, is an individual, is like an individual computer a bit, right? I mean, so on your computer, I'm sure you're aware of this, you have the various bits of hardware, for example, the CPU processor, which does the actual work of calculations and executing commands and instructions. The memory, the RAM, that's connected, which has the transient storage of information in a place where it can be accessed in a fast way. There's the hard drive, be it solid state spinning disk, that has persistent storage that when power goes away, you store the information over the long term. And all of these things work together to do that. And what we see instead on top of that is the software, the operating system. And all of these things really, and this is a very Linux, Unix concept, is that everything is a file and everything's on the file system. So a lot of the container concepts come out of this fact that they're from containers are a Linux concept, at least at the moment, or at least mostly at the moment. And that's because Linux has this concept of everything being a file. Everything you access, a computer program, data, and even things that you may not usually think of as files are files. So for example, the hardware, the CPU has a representation as a file, drivers have representations of files, and things like that on the computer. And you want to have a second computer, and that comes to the concept that having a second computer is the same as just having another file system, okay, that is isolated from the other file system using our computer. And this is one of the key concepts of containers, is that it layers up file systems in a way that keeps them isolated from each other and makes them reusable. So you have layers in Docker terms, in container terms, are essentially views of a file system that are usually read-only, apart from the very top layer, which is the layer you can write within a container. And you layer them up, And then you look down through them and you see the layered views of this file system with the higher layers, if they have different things in the same place, replacing those of the lower layers. So you can use this union of layers to build up the container in terms of a file system. So so Docker actually ends up being a special program that does this layering and manages these images for you and allows you to interact with them in some way. And all container systems do this in some way, and they differ in how they implement it. And so, for example, we'll see Singularity tomorrow works in a slightly different way to Docker, but the key concepts are the same. That it's built up of these layers of file system images that allow you to essentially have multiple computers running on one computer. Okay. And they package them up in a way that can be reused easily. And the analogy here is quite useful. You know, it's when in old cargo ship. I'm from. You may or may not have known from my accent that I'm from Liverpool originally. And where the cargo ships in the olden days used to come into Liverpool, you know, there were dockers who were specialists in unloading all the different types of cargo because they'd come with a hold with the cargo in it, be it cotton, be it other goods, and people would unload them in different ways. It was a time-consuming and difficult process with a lot of chance of error, which when the dockers were all very specialist and you know, it had a lot of skills in those areas of unpacking different types of ships. But then became this. There was this idea of containerization, having container ships instead. And so what you do, instead of packing your stuff in the ships, you pack your stuff in containers, which are standard size, which you can then build your ships, and then suddenly unloading and reloading the ships becomes much easier because you have this standard thing that you know how to use. And containers in software the same way. You have a standard way of packaging things up that allows them to be reused on different computers or different resources in the same way, be that in the cloud, be that on an HPC system, a remote HPC system, be that on your workstation or laptop. So whatever host you have, the container host, it should just work, right? Reality is, okay, it's not quite that simple, but that is the idea behind containers, is you have these isolated sort of virtual computers within the host computer. And this is the concept of virtualization. I mean, I guess a few years ago now, things moved quite fast in computer technology. A few years ago now, the most common form of virtualization was a virtual machine, where it really was like a simulation of a computer. You had a virtual processor, a virtual access to memory, and all these sorts of things. It was like a simulation of a computer. Containers are a more lightweight version because most of the stuff is handled by the Linux kernel underneath, you know, the interface to hardware and things like that, which means that you don't have to replicate all those things, this gives you advantages in terms of speed of startup and size of the virtual machine, of the containers versus virtual machines, and responsiveness and how quickly they can run on performance and things like that, which has meant that they've become very popular very quickly because they're easier to manage and quicker to use than traditional VMs. Cedric asks, can Docker run on a platform that has no concept of C groups? So off the top of my head, I'm not sure the correct answer to that. I don't know if any of the helpers or anybody else in the helpers knows the right answer to this question. My instinct is yes, but it's difficult. One challenge, I mean, the reason we cover Singularity tomorrow, okay, just to go back to these things, is because Docker isn't really suitable for running on a shared multi-tenant system or a closely integrated shared multi-tenant system like a remote HPC system where you have lots of users accessing the same resources. It can work on the cloud because they have stronger underlying sort of virtual machine virtualization to provide security. Because Docker requires root privileges fundamentally because of the model it works on, then it's not suitable for shared systems. So that is why other container technologies such as Singularity, Podman, Charlie Cloud as well, I think, various ones like this have arisen to be able to support use on systems where you do not get privileged access You can't have root access. And we'll talk more about that. Jeremy will talk more about that tomorrow in the Singularity section. So Docker tends to be useful when you're working actually on your local system, or also in the cloud, where you can use Docker, Docker containers easily. Okay, I would have to look up the answers to the C groups question to get the definitive answer for you. So we talked about file system layers. One of the concepts I want to get across is, as well as there's the container itself, which is the sort of the running instance of the thing, right? When there's a container, that's a thing that's running in the background as a virtual system that you can access. There's also the container image, and that's essentially the recipe or the shape of the container, rather than the actual instance that's running. So the container image tends to be persistent, and then when you start up a container or use a container, that's called a container. So the analogy they use here is a cookie cutter, which is quite American, or that's the shape that defines the shape of the container, that when you start it up, it uses that to make a container of the right shape for you. Okay, so the idea then is that a container is essentially a self-contained, complete, separate computer file system, or essentially a computer, right? Particularly in Unix, Linux terms, where those things are just file systems. And if you put your scientific software tools into a container, be it Docker, be it something else, you end up with solving several of our issues. There's a clear record of what software and software dependence used, and their versions and things like that from bottom to top in a machine readable format, and also generally human readable as well. Container can potentially be used on a computer that has Docker installed. Doesn't matter whether that's a Mac, Windows, Linux. You should be able to take the same container, and we'll see people doing that here on this course, right? I'm sure there's something. I'm using a Mac. I'm sure there'll be some people using Windows. We may even have a few Linux people, and we'll definitely all be using Linux tomorrow when we look at the Singularity stuff. And the container also ensures that you can use the exact same software environment on your computer on your other resources, right? I mean, it says exact there, like it's what level is reproducibility happen at. So other things might be different. For example, the Linux kernel version might be different that the container's running on top of. But in terms of the scientific software, the layers that you have control over, then you can try and reproduce that across different computers. So what we're going to look at throughout the rest of today, particularly around Docker, is how we can download and run pre-existing containers, and then how we can create and share our own containers. And then right at the end of today, we also have a short section on, what that means for reproducibility, and talking a bit more specifically about how that affects particularly scientific reproducibility or research reproducibility. So there's some key points here, hopefully, which I've covered through this session. Can I just check what questions people might have about that sort of conceptual material before we move on to the next section, where we check that everybody can actually run Docker and the setups are all working? Feel free to put your hand up or shout out or type something. So why are we? So Gavin asks, if Docker's not used on HPC systems and Singularity is used instead, well, amongst other things, Singularity is used instead, why are we studying Docker today? We're studying Docker, one, because it's a really useful tool, right? I mean, this isn't just a course about HPC, this is a course about research and software in general. So, Docker is a really useful tool that you can use on your own system, and that you can expand up into the cloud with, usually. And one of the useful things about Docker is that generally it comes as a self-contained package to install, particularly on Windows and Mac, and gives you an environment that is then useful for doing work on your laptop and or on your workstation that you can go away and work with for your research going forward. So Docker itself is a useful and interesting thing to learn. Are Docker and Singularity interchangeable in case of a non-HPC system? So that's one of the reasons that Singularity is more difficult, is that actually getting Singularity running on your local system is actually more difficult than getting Docker running. Okay, so Singularity is particularly tailored to remote HPC systems, and you can is designed to be installed on such systems. Now, what we'll see tomorrow with the Singularity stuff is that one of the ways you can make Singularity available, or one of the easiest ways you can make Singularity available on your local system, is to run Singularity within a Docker container. Okay, and use the command, the Singularity stuff for building images within a Docker container. So having Docker on set up and running on your laptop workstation is useful for any local work you want to do on building Singularity containers before they're taken up to HPC systems. Singularity does have some interoperability with Docker in that images, when we'll talk a bit about Docker Hub in one of the upcoming episodes, Singularity can pull images from Docker Hub, convert those Docker images to Singularity images on the fly so you can use them on HPC systems. So if you designed a container within Docker and made it available, then Singularity should be able to use it as well on the HPC systems. So actually, one of the reasons that Docker is very useful is that it's much easier to work with locally and create images, which you can then potentially reuse in Singularity on an HPC system. Singularity is much more difficult to install locally, essentially what it boils down to. Okay. I'll move on to the next section, but if you've got a question and you've missed it, please do type it or put your hand up or interrupt me. I'm happy to answer them before we start the next section. So in this section, which is the last one before, which is I think just the one before break, our first break, we're just the idea of this session is to use the Docker command line and make sure that everybody has a working Docker installation that they hopefully got through set up as part of the setup instructions for the course. So we're going to talk about interacting with Docker and making sure that it's ready to use. So sometimes you may need to log into Docker Hub, or it could just be started up automatically. Usually, if you've installed Docker Desktop on Mac OS and on Windows, which is what most people will be using, though we might have a few Linux people as well, but they tend to have, be more comfortable with this stuff. So what you'll end up with is, hopefully, once it's installed, you'll end up with an icon that will automatically log you into Docker Hub. So if you look, it's quite hard to see because my screen's quite small, but up here on my Mac, I have this icon here, which is the whale with blocks on his back, which is the sort of standard Docker thing. And that tells me that my Docker desktop is running. And it also has my username, which is hard for you to read on my screen because it's very small, but that's my username, ATurnerEPCC, which shows that I'm already logged in to Docker Hub via the Docker desktop. Okay, so if you're on Windows or Mac, you should have an icon that shows you're there. And if you're on Linux, you may have an icon, depending on the flavor of Linux, you may not. So we may need to, for most of the work we're doing, you don't need to start off with, you don't need to be logged into Docker Hub, but you probably are logged in automatically. If you can't remember your Docker Hub username, you can go to hubdocker.com in the browser, and let me start that up. Hopefully it will come up. My internet's quite slow, I think, at the moment. Okay, and you can see I'm logged in up here, and it's got my username up in the top right. So that helps me remember my Docker Hub username. Fine. So assuming that you've got your Docker application running, you need to open everything you will do with the Docker is interacting via the command line. So that's generally PowerShell on Windows or Terminal on Mac OS or on Linux. So the first thing we're going to do is going to just check that Docker's working by typing the Docker ---- version. So I'm going to type that. Oops, too many minuses. So if I run that, it just tells me that a Docker version is some version 19 point something, and it has a build. So can I ask everybody to try that, please? And can you tick yes or no on the poll to let me know what you've done? So I think that means most people have got Docker up and running on their system fine, which is great. So you could also use Docker. You could also use Docker container ls to show what containers you already have there already in your system. Sorry, so let me do that. Docker container show, sorry, what containers are running at the moment. Okay, so Docker container ls for me shows that I have no running containers, right, which is what I expected because I don't have anything running at the moment. You can also use Docker info, and that shows a lot of information about Docker and how it's installed, but it's generally not interesting or useful. This is the sort of area you see if Docker's not up and running. It can't connect to the Docker daemon. That usually means that either the install hasn't worked or that Docker desktop isn't started on the system. But as most people have that working, I will move on. Okay, so there's a couple of questions. Sorry, Charlotte asked, do we need to be able to use a GUI for Docker? I'm doing everything from SSH to a Linux machine. Command line is working so far. So the answer is, in short, is no. There's one exercise later on this afternoon which displays a website, but it's not a critical thing, and it's not a big problem if that doesn't work. So everything else should be via the command line. Okay. Bit of a side question. How is Vagrant used in the case of containers? I've not used Vagrant with containers. I only know it from use with actual full virtual machines, where it's a way of managing virtual machines. What we'll see when we come to creating containers, our own containers this afternoon, is we'll look at the Docker file, which is the specification of how Docker creates images. And in my head anyway, Vagrant is the equivalent of that for VMs. It's a specification of how you create the virtual machine with what software is installed and how it's set up. Okay, so it provides a machine readable way and a human readable way of reproducing the setup of a VM each time. Now, I haven't looked at Vagrant in detail, so maybe that Vagrant supports containers as well as VMs. But that's not something I've used before. And generally, all of the Docker solutions have their own sort of recipe file. In Docker, it's Docker file. In Singularity, it's a Singularity recipe. In other things, it's other things, and they're generally pretty convertible between each other. So I don't have huge amounts of experience with Vagrant. I have used it a little bit with VMs, but I don't know whether it's a thing for containers as well. Okay. If you have the tutorial Docker running, it shouldn't interfere, because one of the whole ideas of Docker containers is that they're isolated from each other. There you go. I used somebody to know more than me. Thank you, Will. Okay, so you can use Vagrant to define and create containers, but it's generally used for VMs, and Docker's used to define and create containers generally on local systems anyway. As I said before, we talked. I don't know how many people are still here, but we talked about we talked a bit about why we were teaching Docker earlier, and one of the reasons is that it's ubiquitous and it's a well-used tool. It's by far the most widely used container technology around the world. So it's a useful tool to learn, and the concepts are the same. So once you've learned the concepts with Docker, taking them to other container technologies that might be used on HPC systems makes things easier, and you're able to use Docker, which is useful in its own right. Okay, so one question that came up over lunch in the chat is for people using Linux, which I should have mentioned right at the start. That if you're using Docker on Linux, you often need to put sudo. You need to run the commands as root, so you need sudo in front of the Docker command. I think there are a few exceptions that will run without root privileges, but most of them will require that. So you should use sudo in front of them if you're running on Linux. If you're using Docker Desktop on Windows or Mac, you don't need to do this. Okay, so most people are back. We've got a couple of people haven't responded, but I think we're pretty coy, so I'll get started again in the interest of time. So we've done some conceptual stuff for containers and what they are. We've hopefully I think almost everybody's got to the state of having a working Docker install on their system. So now we're going to take more of a look at actually running and exploring and running containers and how we do that and what we can use them for. So let's start on that section. So we're going to use the pretty standard on any programming computing course. There's almost always a hello world example, and containers are no different. So we're going to start with the hello world example. As we saw last time, Docker image. We saw Docker container ls, which shows you which containers are running. Docker image ls is the equivalent for Docker images. Now, if you remember the terminology, the image is like the cookie cutter, which is the template for a container, and the container itself is the running instance of it. So you could have multiple running containers that were all based on the same image. So I do Docker image ls on my system. You can see that there are no images at the moment. So that's because I haven't downloaded anything. I haven't started. Depending on how much you've played around already with your install, you'll either have none or something there. So we're going to go and get the canonical hello world example from Docker, and the Docker pull tells us to go and get an image from some remote resource. Now, if you don't specify which resource, it uses Docker Hub by default. So we're going to try and pull this hello world example from the Docker Hub. So let's try that. So Docker pull hello world. So you'll see there's various bits of output from my computer. In fact, it's a bit of a pain in the neck to be able to see that the font isn't as clear as I'd like it to be. So let me just make that white screen bigger, and that might clear up my terminal window a bit. Okay. So it went away and pulled from Docker Hub the image for hello world. Okay, and it used this default latest version of it. And then we got that, and we want to check. Sorry. So we pulled it down, and then we want to check whether we've actually got it or not. So there's an exercise here. So can I ask everybody to have a go, make sure they pulled the hello world image, and then have a go at checking if they can see it using the checking that they can check. Sorry, I'm tangling my tongue up in words here. Can I ask everybody to pull the image and then see if they can find the command that shows that the image has been downloaded successfully, please? I'll put up a poll for people to say if they've successfully completed this, and I'll leave it up this time because that was my problem last time, as I got rid of it. So the majority of people so far have been able to pull the image and show it there. As you guess, because Docker image ls, as you hopefully saw, because Docker image ls last time didn't show the image, you would hope that Docker image ls this time would show that I pulled the image. So the poll's in the way on my screen in terms of showing it, but you can see that before Docker image ls showed nothing, and now it shows that the whole hello world image is there. So let's go on to the next bit here. So, okay, so Docker image ls shows you the list of images. So now we've downloaded the image. We're going to actually run the image, which actually takes the image we have, turns it into an actual instance of a container, and runs it. Yeah, okay, Cedric. So let me clarify. that. So let me do the Docker run and we can discuss. So if I run the image of Docker run hello world, so it prints a message from Docker to show it's working. It says the Docker client contacted the Docker daemon, pulled the hello image from the Docker hub, created a new container from that image, and then that output came to the Docker client, which sent it to your terminal. As just asked in the chat, is well, when running the whole word, the output includes number 2, which is dubious since the image was already downloaded and locally available. So yes, that's true, right? Because it depends how you run this image. Now, if I, excuse me, if I was, we'll see this in a minute, but I could have, instead of doing the Docker pull and then the Docker run, I could have just issued Docker run, and it would have spotted that that image wasn't in my local repository and would have done the Docker pull from me. So because this image is designed for the basic Docker tutorial, where I think they don't do the Docker pull first, they just do Docker run, and then the pull happens automatically in the background because it knows it isn't there locally. So then this description is completely correct. Okay, but yes, it doesn't match. It doesn't match if you already have it, and if I ran it again, it still wouldn't match because we have that image locally, even when we run the container instance. Okay, so when we use Docker run, there's essentially a few things happen, and they're not. This doesn't quite correspond to the things that are in the list from the Hello World example. It starts a running container based on the image. So this is an instance of that image type. Now, then it performs a default action. So most containers have some sort of default action, which is what happens if you issue the run command and don't tell it anything else. And in this case, the default action is to print the message to the terminal that you showed above. But it could be anything else. I mean, it could be something much more complicated. It could run a complicated program. It could run a whole analysis pipeline. It could do anything. That's up to you, the person who designed the image, what actually happens. And we'll see more of this later when we come to create our own images and look at those things. And then once the default action is complete, it stops the container running or exits the container. The image is still there in the background, but nothing is actively running. In fact, the container is still there in the background, as we'll see in a minute, as well as the image, even though it's stopped or exited. And as I said, the default action is to print the message by default in that one. And this answers the question again here. You know, if you'd skipped Docker pull, then Docker run would have automatically done the pull if it about it. If you want to pull things that are not from Docker Hub, then you get, again, we'll see this tomorrow with the Singularity, because we'll pull the Singularity image, Singularity Docker image, which is not on Docker Hub. You explicitly specify the URL of the location to pull from. Without a full URL, it assumes Docker Hub and goes and looks there for you. Okay, so that was the default action, but you don't always want to do the default action with containers. Sometimes you want to run a different command. Okay, so the output above it says when the output above gave you a suggestion what to do, it said you can do something more complicated by downloading Ubuntu. But what we're going to do instead is try downloading and running the Alpine Docker container. You're doing 2 steps or one, using either just the pull or directly the run command. And we'll see what that gives. So let's do it with the run command, which is not doing the explicit pull first. So Docker run Alpine. So what this does is it goes away to the Docker Hub and looks for something called Alpine. Says I can't find them locally. I'll pull it from the library, which is the Docker Hub. And this one takes a lot longer because it's a bigger image. And that's it. It's finished. Okay, so Docker run, in this case, didn't do anything. And that's because the Alpine image doesn't have a default action set. So it doesn't know what, there's no sort of, if you don't give me anything, I don't know what to do. So which is why it didn't do anything. So instead of giving it no commands, we can add the command we want to run to the end of our Docker run command. Okay, so here we're going to add this cat etc os release. So I'm going to copy that. I'm going to do Docker run alpine, if I can spell, and then I'm going to add in the command I copied. Let's give it a moment. And you'll see there was no pulling or downloading this time because the image is local, which we can see with Docker image ls. You can see the alpine image there. And what it did was it printed out this stuff. Now, I don't know how familiar you are or not with Linux commands. Cat just prints the output of the contents of that file to the terminal. So these lines are just the contents of the OS release file that just give you a bit of information about the version of Linux, version of Alpine Linux, which is not very exciting, really. Okay, so can you run this Alpine container and make it print hello world instead of running the etc os release command? So I'll let you have a go at that and give you a few minutes. We're already 26, so I'll give you half past to have a go at that, and then we'll look at the solution. So the question is, where are the images actually stored? Okay, so Docker creates its own little file system repository on your computer within its install. I can't remember the exact paths off the top of my head. It depends on Windows. Oh, there you go, Will. Thank you. Varlib Docker, where it stores the images for you. And we'll look in the next bit of the course. We'll show you how you delete things to free up space, because they can, if you store lots and lots of images, they can take up lots and lots of space on your hard drive. Okay, so we've got half the people who managed to print it. So I'll go and show you my solution. Various solutions may differ. There's also, okay, that's useful to know, Stefano. I didn't know you could do that. So you can set up the settings to store them somewhere else as well. The set up the configuration to store it somewhere else if you want to. So that's the command I had before. Docker run alpine, cat os release. The way to print something to the screen in Linux, or one of the ways, is to use the echo command. And so we can echo hello world. And that just prints hello world back to me on the screen. One weird thing that I haven't quite understood, I don't know why it didn't, and one of the helpers will be able to explain it to me, was traditionally that Marguerite, is that this where containers are stored in Windows, where the images are stored in Windows? Sorry, you're asking. I don't know off the top of my head. All I can do is in the lunch break I can Google it, or if somebody knows, we can put it in the Etherpad. So one thing that was really weird when I was testing this is typically hello world in most computing examples has an exclamation mark, but if you try that, certainly on mine, it throws an error, and I'm not sure if that's because I'm in ZSH or something. It's escaping the character somehow, so I had to add an escape to make that work. I can't even find my escape character at the moment, but that was a bit of weirdness. Anyway, let's carry on with the course. So I think most people managed to get that working, or now have seen how it works anyway. I'll say you have to be clicking on the display of the window rather than the window itself. Okay, so you can provide commands at the end of the Docker run command, and they execute inside the running container instead of the default action if it exists. Now, the other thing we want to look at is how to run containers interactively. So that's, instead of providing the commands on the command line, actually access the command line within the container itself. So you can type commands within the container, which can be more useful than retyping Docker run every time, especially if you're exploring some things and doing some development work in the container. And the way you do this is by providing a shell as the command to run in the container, and passing a couple of extra flags the interactive flag, which is -i, and we also need the -t flag in Unix. In Linux they can command it to 2 -it to run things. In Alpine, usually you'd use either bash or the Bourne shell, sh, as your command. In Alpine, we'll have to use sh because it's such a stripped down version of Linux that it doesn't have bash installed. So to get an interactive terminal, we use docker run -i for interactive, -t, which gives us a terminal, essentially. And the name of the container is Alpine. And the command we want to run is sh, which is the Bourne shell, which is one of the standard Linux shells. So I should run that. Hopefully, it'll take a moment to come back. And what you'll see is that my the prompt where I could type commands has changed. If you're familiar with Linux at all, hash usually indicates that you're the privileged user, you're the root user in Linux. If your prompt has a hash in it like this. And because everything in Docker runs as root, then generally if you enter the container, you'll be working as root. And then I can just type normal Linux commands here. So echo hello world, cat etc os release, which is these are the things we did before. We can use ls to have a look around and see what folders there are here. And this is all running within the container itself. Okay. And so you can try commands, and the useful one is to see what user you are. That's a useful one to run. And you can see our root, which is the privileged user within Unix Linux. And once we've finished doing what we want to do in the container, we can get back to our host command prompt by using the exit command. Okay, and that takes me back to my host computer where I am with my normal ZSH prompt and back again. Okay, so you can all try that. But so there's a slightly longer exercise here that will give you probably 10 minutes to do until 11:45. So the challenge, try and do it without looking at the solutions in the first instance, is can you find out the version of Linux that is installed on the BusyBox container? This is not one we have yet. And can you find a BusyBox program within the container and find out what it actually does? Okay, so I'll give you 10 minutes or so. That takes us to 1:45 to have a go at that. I'll put up a poll for people where they can see whether they've completed it successfully or not. If you get stuck, you have any questions, please put them in the chat or put your hand up and speak, and either one of the helpers will help you or we help you directly within the session. So go away, have a go at that, and see how far you get. And that's the final bit of this section before we go on to the next two quick sections before lunch. So it asks, can we run the image remotely? You must have it locally. So you must have it on the host. Now, in all these examples here, we're using your local system as the host. Okay, but you can have remote hosts, particularly, for example, in commercial clouds. So people like Azure, AWS, Google, the Google Cloud will offer services where you can remote run Docker images. Some of them in a more complex way via spinning up VMs and configure it all yourself, but some of them will offer more streamlined services which allow you to easily spin up Docker containers in the cloud instances. So anywhere you can have a Docker host, you can run the image, or you can run a container. Okay, and that image will be hosted there, and that that could be a remote system, or it could be a local system. We use local system here for convenience, because it means we don't have to go through all the registration and clouds and setting all those sort of things up. But that's supposedly one of the strengths. That's one of the strengths of containers, is that you can take something that you've tested on your workstation and then run it seamlessly somewhere else. if I have an old laptop lying around that can't run a modern OS, you can't use Docker as a workaround. So I think it depends how old it is, right? Because almost all, even really quite old laptops can generally run a flavor of Linux, right? And even a modern version of Linux. And then from that version of Linux, you could use Docker on the laptop. Okay, so you could get use of it, use out of it that way. Now, if you can't install a modern version of Windows or Mac OS on it, then you're not going to be able to use the Windows Mac OS versions. But generally, there are lightweight versions of Linux out there that work with old laptops, and then you can use Docker on them. So that should work. Yeah. I mean, this is just a toy. You're right. So this is just a toy to make sure you're happy getting onto the system and looking into things. So it's not an etc OS release because that's an Alpine specific thing. Proc version should work. So to help people out, because I know one of the trickinesses of this exercise is knowing where to look for the version of Linux. So the place to look for the Linux version is in slash, as I can't skid list, was proc slash version. An etc issue apparently as well, Jeremy. Cool. So I think this is illustrating the classic Unix problem, is that there's like so many different ways to skin a cat. Right? I mean, and that was one of the reasons that Unix was designed the way it was by the original people who wrote it. Okay, I'll quickly show you. We'll stop there for that one. I'll quickly show you the solutions list. There were two ways of doing this. You can either do it interactively by logging into the container, as we saw before, and then looking at the two commands, looking at the two things. For example, proc version or uname-a, as Cedric said, or etc issue, as Jeremy said, and then exit out at the end. Or you could use individual commands, which is a simple way of doing it. You can cat the thing in a little busybox. Busybox is a way of providing a lot of Linux or Unix utilities within a single program for places where you can't do, for example, an installation of full Linux, or where you've only got very lightweight or limited space available to install things. It's often used in embedded computer environments where, for example, within network switches or things like this, where you want some of the commands, but you don't want to install a full version of Linux, which would take up too much space. Thank you, Jeremy. That's a useful clarification as well. So we've been able to download Docker images. We'll use them to run commands in a number of different ways, either to run the command that's set by default. If you remember, they had a default action right back at the start. Some containers have a default action. We can issue our own commands to run inside the containers, and we can even go into the containers interactively and run different commands. So I've got a couple of final sections before we stop for lunch, a couple of short ones. The first one's a very short one about finding containers on the Docker Hub. Now, one of the things you have seen in the last session is we don't give much qualification in terms of the name of the container. It goes away and finds what it can find on the Docker Hub, matching that name quite quickly, or quite easily and quite transparently. So it's useful to be able to know what is around on Docker Hub that we can find. So I'm going to go to a particular Docker Hub, and one thing I would say is worth pointing out is that Docker Hub is very tightly integrated with Docker and the Docker command, but there's lots of things you can do without ever accessing Docker Hub. I think generally most people do end up accessing it because even when they're building their own images that they're maybe not going to share on the Docker Hub, they'll generally use base images that come from Docker Hubs, because a lot of the official releases of things like Python, R, and various flavors of Linux are all there and are officially supported by those people. So it's usually a very good go-to place to start from. Anyway, so let's have a look at the official Docker release of Python. So I'm going to open up this in a new browser window. And then once it appears, I'll make it a bit bigger, so hopefully people can see more clearly. I think it's being very slow because I'm actually teaching and sharing my video and audio and all that sort of stuff at the moment. Okay. Make this a bit bigger. So, there's a lot of stuff on Docker Hub, and sometimes that means you need to be a bit careful about what bits you use and what bits you don't. And my experience when using Docker Hub, I tend to start from official images from people. For example, so if I'm doing some with Python, I'll start with one of the Python issues. Sorry, one of the Python official images. The same for things like R and things like that. There's lots of on this Python page, and it gives you a few bits of information about it. There's the different versions for the different architectures, from say ARM architectures, PowerPC, which is IBM's architectures, x86, which is standard PC type, standard PC setup. It gives you a bit of information about what it is, and then it gives you some information about the different versions of the container. Of the image available on Docker Hub. And you can see for Python, there's lots and 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 lots of different versions. But if you scroll right down to the bottom, some of the useful things they have are, it describes what this image is, and then how you could potentially use this image in either a Docker file, which we'll talk about later, or running a single Python script. And things like that, and it has some description of the different versions. So there's Python version, Python version Slim, which it makes it smaller, for example, and Alpine versions, all these sorts of different things. What I've found generally on the Docker Hub is that the documentation is actually pretty good for the official images, and usually this sort of example section about how to use this image is really useful for getting started, and you can generally find something that matches onto your use case. Is the Docker file for this particular image available on Docker Hub? So this one, the Python one, yes. So this is the Docker Hub. This website is the Docker Hub. So this is one of the ones that is there on Docker Hub, and you pull it, and this command here tells you how you'd get it onto your local, and you'd get the image on a local system, which is simply Docker pull Python is the simplest. Right, you can just get the standard, the sort of default Python version. If you want a specific version, then you can add more information to download a specific version. Okay. So the Docker Hub has lots of different things. Oh, can you see what Docker files people have used to create the image? Okay, sorry. Yes. The question is, can you? I don't know if it has that right at the bottom about whether it actually has the Docker file or whether it has it up here somewhere. I've never actually looked for that to see if it actually has the Docker file in there that they use to create the image. So I'd have to go away and look for that, I'm afraid. Sorry, I don't know that one off the top of my head. Yes, Gavin, we're going to talk about Docker files in a bit. They're how you create your own Docker images. Okay, so I'll have a look at how you can find out the Docker file for existing images as well. Okay. So as I said before, you can pull different versions. If you pull the standard Python, you get whatever the latest and current the latest stable release is. If you want to pull specific versions of Python, you can append that after the colon on the image name. And although you get, like I've said, there are images provided by the official Docker team, which are the sort of the official images. You can see ones that are provided by individual owners or organizations as well. So, for example, Continuum.io, the people who do Anaconda, will often provide Docker files for Anaconda Python, and Rocker are a community that provide R containers with R built into them, for example. And we've called them image files, but they're really, in Docker Hub terminology, they're called a repository. This is slightly confusing because they're slightly different from a repository in the sense of Git or SVN or other repositories you would have come across. So there's an example. There was an exercise here. Was how would you download a container produced in the Rocker group that has version 3.6.1 R and the tidyverse installed? You could go away and look on Docker Hub and search for Rocker R and look on the web page. But you can look, if you did that, you'd come and find that you wanted Rocker/tidyverse 3.6.1. So this is the people providing the container image, providing the repository. This is the name of the repository you want, which is the tidyverse version, and it's version 3.6.1 of R, and you can pull that down there. And there's lots and lots of containers on Docker Hub and on other image repositories, and it can be a bit overwhelming if you find the one you want. But as I've said, sticking to the official ones as bases to build on is a useful thing to do, or things that have a large community support behind them. If there's something provided by a single person, unless you are just actively working with that person, then you need to be I think, a bit more careful about what you're using and how you're basing things on. So, but often there's something you're pretty clear about where you're starting from, right? So if you're building something on Python, you often start from one of the Python containers. And if you're building something based on R, you'll often start from the Rocker containers and things like that. And we'll see we'll get more concrete examples of these as we go on through the lesson. So hopefully you'll get a better idea of what I mean by this as we go on through the lesson. So the Docker Hub has a large repository. There are other repositories out there. We'll see one tomorrow associated with Singularity, which is the key IO one. Most people start from some sort of trustworthy either official images or images that have very large community support behind them, to make sure that they're getting the right sort of versions. Do people have questions on Docker Hub before I move on? I realize I went through that quite quickly, but I want to move on to the actual running images and getting to, for example, what Gavin's question is about what a Docker file is, because we've mentioned them a few times before we stop for lunch. Okay, fine. So just before we get to lunch, one thing that people asked is about how they clean. There was about where they're stored and how they clean up. We talked a bit about where they're stored, and we could try and clean up using the equivalent of the RM command. So let's list the images. Is there any way to check for versions available when using the Docker search command? So Jose, I typically have to say I typically go to the Docker Hub website and use the search there. So if I'm searching for Python, I would end up here. Let's search for. Oops. Oh, sorry. So I tend to go and search for the images using the website interface rather than the Docker search on the command line. And now I know Docker search is there on the command line. I don't use it very much, I have to say. And from once I'm in here, I've found, for example, the sort of image I want. I can look at tags. It's quite slow, my internet, because of the streaming video and stuff. and you can see all the different versions here. So there's the latest one, for example, there's 4.03, and you know, you can see which ones are available there, and then use that to. And each of these tags has an example of how you would get that particular version as well, in a similar way to the sort of top level page for a particular repository. Yeah, okay. So sometimes they're available, sometimes they're not available. Fine. Yes, okay, there it is there, yes. Right, so cleaning up. So I can see what images I have with Docker image ls. You can follow along with this and run these commands at the same time. So say I wanted to get rid of the hello world image. Okay, so use this thing here. So I'm going to try Docker image rm remove, and then I'm going to get this string and try and remove it. Okay, and the first thing that it tells you is that the image is being used by a stopped container. Now, remember when we stopped and exited containers before, I didn't say they were removed or deleted. I said they were stopped or exited. So what this is telling me is there's a container that's using this image, so you can't delete the image yet. So, okay, so let me go and look at the containers. So maybe I could get rid of the container and remove it. So there's Docker container ls, which is the equivalent for containers, but there's nothing there. Okay, and the reason for that is that Docker container ls only shows running containers by default, and we've got no containers running at the moment. They're stopped or exited. To show the stopped and exited ones, we need to use the -all flag. Okay, so now we can see more, actually. So we can see there's various images here that have exited, and you can see the hello world one is down here. So all the other ones have been the Alpine version, and the hello world one was down here at the bottom, and you can see it exited about 40 minutes ago. Okay, so to be able to remove that image, we're going to have to remove this container first. So we can do Docker container, oops, if you can spell, rm, and then we can use the ID. There's two different things that you can use. You can either use the ID. You could also use the name, which is an auto-generated unique name, but we'll just use the ID in this case. So let me get that. And the ID will be different on your computer, obviously. Okay, so that one has removed that. We can check it's not there anymore. Okay. So now we can hopefully go back, look at our Docker image ls again, and the Docker image rm was the BF756 one. Let's try that again. Okay, and this time it worked because we removed the container. There was the stopped container that was associated with it. So hopefully if I Docker image ls now, there's just the Alpine container left. Okay, so one useful command if you want to get rid of all your stopped containers, because they can build up over time. The two different things. One command you can use to get rid of them is Docker container prune. That gets rid of all the stopped containers, and it gives you a confirmation. So if I do a Docker container ls --all, now that'll be empty because all the containers are gone. The other thing you can do is you can add. So we essentially went through all this. This is what I've just done. ls --all. You can also add the --rm when you issue the Docker run command, and what that says is when the container stops, remove the stopped container, delete the stopped container as well, and keep things tidier. And people, it's generally quite good practice to do this unless you're working with with that container over and over again in short succession, because what having the stopped container does, it means it's quicker to start up and get going. Anyway, we removed the container, we did all this, we pruned the containers, we showed that, and then we removed the image. Okay, so the whole point of this section, this was just a quick short episode in the lesson, just to show you how to remove containers, because it can be quite confusing when you try to remove an image and it tells you it can't because there's an image, there's a container, and you can't see the container running. It was just to point out that stopped containers can exist in the background. You have to use the --- all flag to see them, and you need to do that before you can tidy up the images itself and reclaim the disk space from them. Okay. I went through that quite quickly, so I'm aware there might be some questions. So while I'm moving on to the next section, if people have questions, please feel free to ask them about removing images and managing images and containers. Yeah. Okay, so I'm going to start this next section, which is the bit about how we start to create our own container images, where we'll cover Docker files. We'll start to cover Docker files that we've mentioned a few times already. I'm not sure we'll get to the end of this section before lunch, and as I said before, I don't really want to curtail lunch because people need a break, a proper break, because when we're learning online like this, people need more of a break. So we'll go as far as we can go. I'm going to stop at around 12:20, and we'll go for lunch then, and we'll pick up wherever we are in the afternoon. We've got plenty of time in the afternoon session to get through the remaining material, so I'm not worried about time at all. So please feel free to stop me again, ask questions if things aren't clear, and do our best to help out. So in this section, which is one of the most important sections, I guess, we're going to learn how we can make our own Docker images, understand what a Docker file is and how it fits together, and then go through the steps of actually doing this. And then after this section, we'll look at more complicated examples of creating images, because we're going to do something very simple in this one. So the first thing I should say is there was a small step in the setup section that we need to complete before we start this. Oh, just a minute, I've frozen something. Oh, there we go, we're back. Okay. We're going to download a zip file to use as part of this part of the lesson. So if I skip back up to the top level, in the setup section, there was a file to download. You may have already done this, that's great. If you haven't, then you can do it now. So I'm going to download this Docker intro file. And then I'm just going to go and find it, and it'll be in my downloads folder. I just need another window here to copy it across. So Docker intro 1.zip. I'm going to move it over to where my working directory is. And I'm actually just going to rename it to get rid of that horrible one, because I've downloaded it before. Okay. So I've copied it into this directory, which happens to be the same directory I'm working in here on my local system, and then I'm going to unzip the file. Okay, you can do this through either a graphical browser or on the command line like I've done. And this should create a directory called Docker intro, which I'm going to go into, and then I'm going to go into basic for this part of the lesson. Okay, and there's a file in there called Docker file. Okay, so if you've done that already, that's great. If you've not, then you'll need to do that before you do the example. So I'm going to skip back to the part of the lesson we're at, which was the creating your own container images. I'm going to get rid of that. Okay, so let's have a look at how we can install software in the environment. So let's run our Alpine container that we downloaded earlier, and run an interactive shell in it. So Docker run -it Alpine Okay, so you can follow along. If you can follow along with your own ones here, I think that helps here. So let's try running Python, or Python 3 even. Okay, and I don't think Python's found either. Try either of them. So because it's a very basic install of Linux, there's no install of Python in there. But what we can do is we can add our own station. But this is just, it's a virtual machine. We're root. We can install whatever we like here. So within Alpine, the tool to install additional packages is called APK. In other Linux distributions, it's other things like Yum or apt-get or Zipper, depending on your flavor of Linux. But in Alpine, it's APK. So we're going to do APK add minus update, and then we want to add Python 3. We want pip, so we can install other Python packages. And we're also going to have the, I can't spell pip, Python 3 dev package. Okay, so let me go there, and it will go away to the repositories where the packages are stored for Alpine Linux, and go and fetch them for me. The dependencies that are required, plus Python itself. So it'll just take a moment to install that. It's the Python bit that's the big install. So this is the same way you'd install if you had just an actual physical system with Alpine Linux installed on it. It just so happens that we're inside the container rather than on my Mac system. Okay. It's going very slowly right now because I'm streaming and doing all these sort of things at the same time, okay. So now we've got Python 3 installed, so we should be able to do great. Okay, so we have a version of Python and it works as expected. I think if I do Python 3, we get into the Python prompt and everything just works. It all just works. So let me pop out of there back to still in my container. Okay. Oops, clicking the wrong place again. And now we've got pip as well. We installed pip there as well, so we can use pip to install things as we usually would. So let's install a Python package using pip. It'll be a bit slow because my computer's a bit slow because it's doing lots of different things right now. Off it goes. And it does its thing. Okay. So we can install all these things, and that's great. And now we've got a working. It's okay. I do that all the time. The typing Unix commands in the wrong window. We've got a container with potentially the things we need in to run our analysis or whatever we want to do. The problem is now, of course, when we exit our container and then go back in, I'm pretty sure that Python 3 is not found, right? Because all that work we did to do the installation has been lost because the container itself is a transient thing, okay? So what we want is a way of building the image. Why do I get an invalid syntax? I think we need a bit more details to at what point and in the container between pip and what do you mean between pip and install? So that's one command, pip install. Okay, one of the helpers will help you out, I'm sure. So once you've installed things, if you then exit the container, you've lost. Okay, there are commands that you can snapshot your changes, but this isn't really the reproducible way to build containers. Yeah, I'm not quite sure what's going wrong there. What happens if you just issue pip install Cython without the Python 3 -m at the front? Oh, I see. Okay, so you're in the Python command line. Yeah, you can't use the pip install command from within the Python command line. Sorry, I'd missed what was going on there. So those changes aren't saved by default. Okay, so what we want to do is capture the commands that we use to set up our container in some way where they can be reused to build a container image that can then persistently have that set up in it. And that's what the Docker file does. A Docker file is the series of commands used to set up your container. Okay, so within our shell, so within the shell within the directory, we were looking at the basic directory. There was the Docker file here, and if I look at the contents of that Docker file with cat, which just remember prints the contents of the file, it has a few different bits and pieces which make up the basic level of the Docker file. There's a from where you provide the name of an existing image that you want to build your custom image from. Okay. Then there are commands such as run. You can run install commands from the shell, as we did interactively, but it will do them to build the image for you. And then finally, the CMD, which tells it what the default action is, or the default command to run is when the container is run. Okay, so in our case, we want to replicate what we did interactively up here, but within the Docker file itself, so it's non-interactive. It's non-interactive. So what we want to do is use the Alpine Linux as the base container, add Python and Cython, and set a default print command that says, I don't know, prints out hello from the container or something like that. So let's have a go. Let's have a go at doing that together. I think rather than you doing the exercise, we'll do this one together. So the first thing we need to do is open the Docker file in a text editor. Now it could be whatever text editor you like. I am going to use VS Code, but it's up to you what you use. VI, Emacs, TextEdit. You can use it. You can access it from the command line or from graphical user. It doesn't matter as long as it's just a text editor. Okay. So I'll do that and start up Visual Studio Code. Okay, and I'll make that a bit bigger. Hopefully, I can. That was working. It was just being slow. Okay, you should be able to see the commands there. So I'm going to change this one, and it's going to be from Alpine. And then the commands we issued on the command line were, it was APK install. Sorry, this has been really annoying. It was APK add, wasn't it, actually? -- update Python 3 py3 pip Python 3 dev. I'll double check that in a moment because I'm not very good at remembering things, but I've got that right. And then there was a pip install Cython. And then we want to run some sort of command by default. So I'm going to use it to actually check that Python is installed and print the version back of Python. So Python 3 -- version. Let's try that. Let's see if that works. Okay, so my Docker file here is saying we're going to base it from the Alpine Linux official container. Then we're going to do these two things to modify the container, and then we're going to set the default action as that. Let me save that. So I've saved that now. And I also want to double check I got the APK command right because I'm not very good at remembering that APK add Python py3 pip dev Python 3 dev. I think that's right. Let me see. Right, that looks okay. That looks okay. That's saved. So once we've done that, then I can build my container using the Docker build command, and I can give it a name with -t. So one thing to notice on here is this dot at the end, which refers to the current directory, that's where to find the Docker file. Okay, and in this case, the Docker file's in the current directory, so we use dot. So let me try that. So Docker build -t. I'm going to give it the way I'm going to name it is going to use my Docker Hub username, and then a slash, and then the name of the container I want. So this is going to be an Alpine Python container, and I'm remembering the dot, which is where the Docker file is. Okay, I'm going to press enter and see what happens there. So it goes and looks at the Docker file in the current directory, and as you can see, here's the lines from Alpine. So it uses the Alpine container that we've already downloaded, we've already pulled from Docker. We know it's here because we didn't delete it. Then it does the run command, which is the apk add update python py3 pip python3 dev, and you can see this is it's printing exactly what it did when I did this interactively in the container. It's doing exactly the same thing as it did in the container. I'm putting this together. If you remember right back to the very start of the thing where we talked about layers and the concept of containers, each of these commands is essentially a layer within Docker, overlaying each other in sequence. So starting from the base layer, which is Alpine, okay, and then layering on top of that the Python install. I will see in the moment, it'll do the next layer, which is the pip install. And then the final layer in our Docker file is building the default, is adding in the default action to run when we run the container. Okay. Okay, so installed hopefully the Python packages, and it's still working. You can be running this as well at the same time on your local system. So now it's the next layer, which is the run the pip install Siphon. Okay, this is actually the layer identifier here, this ID here, that gives you this running in. So it runs in this intermediate container and produces a layer. Okay, so it's done that. It's downloaded them and it's installing them. So hopefully we're near the end now. And then the final layer is this setting the default command. And it says it's created an image. So it's created an image and it's successfully tagged it with the name that I gave it. So let's do, I'm going to stop in just 1 minute. Docker image ls. Excuse me, and they can see this one that was just created 2 seconds ago. It's quite large because it's got Python installed in it, Alpine Python. So I should finally be able to do Docker run, and then the name of this container. Sorry, I'm not very good at picking it up. It'll take a moment to start up, and it prints out the version of Python because the default action was to run Python 3 -- version. Okay, I hope that's reasonably clear. We'll talk when we come back after lunch. We'll talk about more detail about Docker files and check that you are all able to create a container in the same way and build it in the same way as that. So I'm not expecting you to do that over lunch. If you haven't already managed to build the Docker file, then we'll pick it up again straight after lunch. Yes, exactly, Paul. So run specifies things that you run, commands that you run when you're building the image, and the command is the default thing to do if no command is specified when you Docker run the image at runtime. That's exactly right. But we'll review this straight after lunch and work through what the Docker file said, what it produced, and what that means. So we'll look at that in more detail then. Like I say, I'll be back early, hopefully, to answer any questions or any issues people are having. If people are having issues with logging onto ARCHER2, we're happy to look at those things too. Yeah, so this afternoon we're going to look at creating more complicated images. We'll talk about how to include local files in your images, which is the bit we haven't talked about at all yet. And then we'll finish up with some notes on reproducibility and what that might mean in terms of containers and how we might capture that. Okay, thank you everybody for your attention this morning. And yes, we'll pick up. I'll see you this afternoon, later on this afternoon.